All right, welcome back. I hope you guys are doing well. Hopefully, you had a good weekend. Hopefully, you guys are staying warm out there. It's getting a little chilly out there. They're calling for snow potentially this week. So brace yourself. Get those shovels ready. Get those extra layers ready and prepare. Preparation's the key to success. All right, please check the attendance to the left. Please make sure it's accurate, precise, ready to roll, just like everything you do in life, and especially in chemistry. Missing a few. Maybe they'll roll on through as class progresses. Please let me know if it's not right. Please unmute yourself or throw it in the chat. All right. So welcome back. Happy Monday. The quote of the week, new quote. Science is simply the word we use to describe the method of organizing our curiosity. So it's the word used to describe the method for organizing our curiosity. Tim Mitchin said that. The daily agenda for today, Monday, October 26, 2020, is day 2. Unit 2, we're going to do a quick little lab, maybe 40 minutes worth of a lab on identifying substances. We'll go around the lab of the class and we'll identify something as an element, compound, or a mixture, whether it be homogeneous or a heterogeneous mixture. Once we're done with that, we'll get into unit number 3, which is the atom. We will start topic number 1, which is the history of the atom. A flick will play, and then we'll get to some notes. Probably won't get through the second video for today. I'll save that for next class, and you probably won't get to the exit pass today as well. Additionally, the 2 things you'll need for today's class for the second half of the class are there. But we're going to start off with lab, identifying elements, compounds, and mixtures. It's right here on the upcoming section here. So please click on that, click it, and then you're going to see it's going to be a lab that we will complete in class today. So I already did this lab 2 times from the other classes. Hopefully yours is not highlighted. I'm gonna have to pull up a different lab, so I don't think yours is gonna be highlighted. Good. So I hope yours looks like this. All right, thanks, Jordan, for letting me know. I don't, just tell them to click, I guess. Tell them to click the link on the stream. Tell them that one right there. Not sure why. Oh, that's why. Because I copied and pasted the wrong class. So just tell them to click the link on the stream. That's the one we're in. I have 3 different Zoom links, just so everybody's aware. I have 3 different sections of Regents Chemistry. I messed up. I should transfer this over. There's Michael. Maybe that was a problem with him. Hey, Michael. So this is period 1, 2's link. I made a mistake when I did it. Hey, Tristan, welcome. I know there's a problem with the link, so I apologize about that.
Wait, where would we find the link? I'm confused.
Oh, you're in, so you're good to go. But everybody else, if you ever have a problem with that, when I pop up my class, I just click on this link right here. I usually update this so it says period 6, 7, and then that's your link. But there's another link that is here, which maybe Santino is probably trying to open up right now. So in case you're having a hard time getting in and there's a class going on, if you guys ever go through this stream, because this is the one I always click when I open up my stream. And it should be like yesterday's last class. It's going to say, let's see here. This is last week's class. So that's the right one. Period 6, 7. That's the link for 6, 7. That's the same one on classwork. Maybe Santino was under classwork. He's popping open this one. That's the wrong one. I'll try to do my part and make sure it's right for next time. But sorry about that. Questions on that? I know it was a little confusing. No problem, Tristan. We didn't really do too much. But anyways, just open up lab, identifying elements. Boom. Click on that. And please take 4 minutes, 3 minutes to read through the background, the material, and the procedures for today's lab. So let's give you, I don't know, 3, 4 minutes. So let's wait till 11:50. Please read through the first 3 paragraphs. Okay, if you're just joining in, please open up your stream and please open up lab identifying elements. Click on that. Give them like one more minute to read through this little section here. First 3 paragraphs. All right, hopefully enough time to read through those first 3 paragraphs. You should definitely know what an element is, you should know what a compound is, and you should definitely know what a mixture is, at least by the end of this unit. You already finished a unit, you had a unit test last time. Those are things you should be definitely aware of. So we have this flow chart behind me. We have matter, we have substance, we have mixtures. You should know what an element is, a compound, and a mixture. So those 3 things we're gonna be identifying today in lab. So what's going to happen here? We're going to go to 12 different stations together. I'm going to roll around on a cart and I'll go through 12 different little stations. You'll identify a substance as an element, mixture, or a compound. Below, there's that flow chart that's behind me as well. We have matter, pure substance, mixtures. And then again, you're going to be identifying these 3 things as either something as an element. Notice that there's just one little element in that little particle. Next one's a compound, like water. There's 2 H's and an O, 2 H's and an O. That's 2 or more elements in fixed ratios. A homogeneous mixture, and then you have a heterogeneous mixture as well. So you should definitely be able to identify anything that I give you today in class, in lab. So scrolling on down, there's going to be a data table, which we will be going through 12 different stations. I'll be starting off with station 1, and we'll be able to identify all the properties of that throughout. So let me readjust. I'm going to put you guys in my cart. We're going to go rolling around the classroom and figure this out together. Congratulations, I put you in groups, and we're all in a group together today. So you don't have to worry about who's friends and who's not friends today, because we all get along. All right, group number 1, station number 1, starting on off. So I'll guide you through this process. So station number 1, we have this little substance here, I'll say. I was gonna say something else. But you could analyze this and you could say, oh, you can figure out what phase it's in. You can figure out the colors there. I know it's kind of tough to see, but you can analyze that. That is gonna be oil and water. So the first station is oil and water. So what we're doing, we're gonna write oil and water under, let's see here, name of substance, oil, and field trip, here we go. Jump on board, everybody. Water. So oil and water. I'm gonna put a background color here. You do not put a background color. You don't have to waste your time with it. That's totally fine. So the first one is oil and water. The symbols, sometimes the index card is going to have the symbols given to you. Sometimes it's not going to have it given to you. So in this situation, we know what water is, which is H2O, but we don't know what the symbol for oil is going to be. So in this situation, we're going to say it's not available because there's going to be several compounds in oil. So Na means not available. The color of this thing again, see it move around. You definitely have transparent or clear on the bottom layer. Then you can see the oil on the top layer. You can see there's different densities there, which give it different properties. You could separate this pretty easily. Field trip. So color I'm going to say is yellow on top, yellow, and clear. Phase of matter. You can see this. Somebody in my other class want to know, how'd you know if it's solid, liquid, or gas? I could go through that with you too. If this one's free flowing, you can see it's moving when I rotate the bottle around. Solid particles, the shape of this would not change. If it's a gas in there, you're not going to see the particles. They'd only be trapped inside of that. So this right there, it's a liquid. How do I know that? It's because it's free flowing. The volume changes. So I'm putting an X under the liquid. You don't have to put the dashes here. I'm going to as well, just so I don't leave them blank. And is this an element, compound, or a mixture? For station number 1, please put in the chat what you think. Yes, Tintin. Yes, Faith. Okay, is it a homogeneous or a heterogeneous mixture? Everybody's put mixture. Good job. It is a mixture. Homogeneous or heterogeneous? Yes. It's a heterogeneous mixture. So it's not an element. It's going to be several things together. It's not a compound. It's going to be a heterogeneous mixture. Heterogeneous mixture. So you can move these tabs around if you want to. You don't have to. Bothers me a little bit, so just gonna make these a little smaller so my texts are on the same level. So 1, oil and water, station 1 is completed. Okay, next up, on to station number 2. Okay, station number 2, we have this substance right here. What this is a pretty thin sheet of foil, but it's not aluminum foil, which you're probably thinking of foil. This one's gonna be copper foil. Station 2, copper foil. Okay, so substance name of substance is copper foil. The symbol or formula. What's a symbol or formula for copper? Yes, Tintin. Copper symbol is Cu. So I don't expect you guys to know this yet. Maybe some of you guys do. If you want to know what the symbol is for an element, you just type it on a new tab. What is a symbol? This symbol, not Timble. Symbol for copper. Pull it on the tab, put it into Google, and you get copper symbols. Cu. Cu is cobalt. Cu is cobalt. Cu is going to be copper. Once you use these more and more, you'll be better and better at this and identifying elements. There's copper again. Color, I'm going to call it copper. Copper color. Solid, liquid, or gas for copper. Anybody? You could unmute yourself, or you could just put in the chat, thank you. It really threw me off the other last class when people want to know, how do you know if it's a solid, liquid, or gas? I think they're serious. All right, element, compound, or symbol. Element, compound, or mixture. Yes, Faith. That's how I felt too. Yeah, it's going to be an element. So these are going to be an element. Not a compound. It's not a mixture. So another thing to analyze, copper has just one symbol. It's also going to be on the periodic table of elements. So if it's going to be an element on the periodic table of elements, it is going to be an element. So copper is Cu. If it's one of these 118 elements, it's going to be an element. Copper, it's on this periodic table. It is Cu. It's right there. Boom, right where my mouse is. Cu, it's an element in the periodic table. If it's there, it's going to be an element. Maybe I'll leave this up here for us too. So that's going to be an element. Okay, station 2 is done. If I go too fast, slow me down. Okay, on to station number 3. Station number 3, the substance looks like this. That is just chalk, old-fashioned chalk. Chalk. And station number 3, the symbol is given to you. Chalk is CaCO3. So station number 3 is chalk. CaCO3 is a chemical formula.
Is the O capitalized?
Yes. Chalk. And the symbol is Ca, which is calcium. Then you have a capital C, which is next to it, which is carbon. And then the O is capitalized. That means there's oxygen, but there's 3 of them. So control, comma, brings you on down. That tells you there's 3 oxygens there. So really, I know we didn't get too far into this yet, but you have calcium, you have carbon, and then you have oxygen, 3 of them, 3 oxygens in there. Color of chalk is definitely gonna be white. How did I get that observation? I just analyzed it. If you're colorblind, then please let me know, and then you won't be able to get the physical characteristics of color all the time. More males are colorblind than females. Don't be ashamed. Solid, liquid, or gas. Again, we're going to look at that and say, oh, it holds its shape pretty well. Since it holds its shape pretty well and doesn't break, it's not free flowing, it's going to have to be a solid. Thanks, Joey. So that's a solid. Element, compound, or mixture. Good. That is going to be a compound. It's fixed ratios there. Compound it is. Okay, that's chalk. Rolling on back. We have the next substance. Iron filings. Iron filings. Here we go. There you go. You see it better now. What does it look like? Iron filings. Here we go. It looks like a sample of, like, I don't know, I guess probably looks like the dirt in your screen or some sand, but it's pretty small little particles. Looks like a little powder. So this is like filings off of metal. Or if you sanded a metal of iron, these would be like the extra particles that would be present there. So again, iron filings, station number 4. What's the symbol for iron? The symbol for iron. Yeah, it's Fe. So some of you guys may have known that. The symbol is going to be Fe. The color on this one, color of iron filings, looks like a brown. Yeah, it looks like brown. Some people from the other class said gray. But from what I'm seeing, maybe it was just Just a reflection of the screen. From what I'm seeing, it looks like a brownish color. Maybe you see brownish gray, but it should be like a brown. Thanks. So brown. That may look like it's free flowing. I guess it may in this situation, but those are just like little granules, little powders. So it's moving when I touch the edges, but if I were to pick a piece of it up and magnify just a piece of it, we would figure out that that's going to be a solid particle. Dirt and a solid particle. If I just take some dirt and I roll it around like that, it's still going to be a solid. So that is solid. Element, compound, or mixture. Good. It is an element. It is on the periodic table of elements. So iron is on the periodic table of elements. I don't know what this video is over here, but hopefully it's appropriate. So if you find an element here for iron, it's going to be right there. That's going to be on the periodic table of elements. Therefore, it's an element. Does anybody need time for stations 1 through 4? Anybody need more time? Good. I'm going to keep going. Station number 5, next one on up. This one is baking soda. Station 5 is baking soda. NaHCO3. Baking soda. A lot of applications you could do with baking soda. Could be used for a cleaner at the house, could be used for scrubbing, could be used for clean teeth, laundry, neutralizing refrigerator. NaH, so that's sodium. And then you have a carbon, and then you have 3 oxygens. Again, to get that subscript, it's just control, comma. So sodium, hydrogen, carbon, then there's 3 oxygens there too. Baking soda. We have some at the house. You know what this looks like. Oh, great. All right, never mind. Just spilled all over my keypad, but it is white. It's a small white powder. Sorry. Wasn't blowing you guys kisses. I was just blowing the powder away from my keypad. All right, so it's definitely white. Solid, liquid, or gas. Formula again, sure. It's definitely a solid going to be. So NaHCO3, it's a solid. No problem. It's also on the sheet too that we have here. Solid, liquid, or gas. We said solid, element, compound, or mixture. Good. It's a compound. For some reason, you guys are understanding the difference between a compound and an element a lot easier or a lot better than the other classes. So good for you guys. So that is going to be a compound. It's a fixed ratio of 2 or more elements. Mixture is going to be, if it's a heterogeneous or homogeneous mixture, it's going to be like 2 or more compounds together. So if I have like 2 compounds, then that would be a mixture. Like this one's, the first one we did was going to be like water, which is H2O, and plus basically oil. So if I took those two compounds and have them together, that's a mixture. Next one on up, number 6. Here's a sample. It is not a dehydrated urine sample, but it is actually Lipton iced tea. Lipton iced tea, it's a green tea citrus. So station number 6 is iced tea. Sorry to gross you guys out initially. Just iced tea, guys, come on. Iced tea. I don't care about the brand. If I look at the symbols, there's no symbols there for iced tea, but we know there's water in there. We know that there's probably going to be some sugar in there. We know that there's going to be some tea in there too. So the formula, if you look at the ingredients in the back, if there's more than one compound, then it's got to be a mixture. There's several ingredients in there, but this one has water, high fructose corn syrup, citric acid, natural flavoring. There's a lot of stuff on the back. I'm not going to really be able to zoom in on that too well, but there's a lot of them in there. So this one is going to be not available. I'm not going to put all those down there. Color, I'm going yellow. Solid, liquid, or gas. I think we all know that that's going to be a liquid. Element, compound, homogeneous, or a heterogeneous mixture. Please put it in the chat. Different answers here. I have heterogeneous mixtures, I have homogeneous mixtures. Heterogeneous, homogeneous, heterogeneous, homogeneous, homo, hetero. Analyzing this thing, if it's the same consistency throughout, then it's going to be a homogeneous mixture. If there's like particles that you can see in there, you see like some tea or something in there, sugar, if you see that in there, that would be a heterogeneous mixture. Since it's the same consistency throughout, it is. You need me to get away from it. Same consistency throughout, that's a homogeneous mixture. So that one's a homogeneous mixture. Okay, next up, station number 7. We have this substance. That's in your probably your kitchen somewhere. All that is aluminum foil. So aluminum foil for station number 7. I'm sure you all know what aluminum foil looks like. 7, aluminum foil. What's the symbol for aluminum foil or formula for aluminum foil? Yeah, Al. Aluminum is Al. If you don't know that, you could, again, pull it into this. Say, what's the symbol for aluminum? Al. There it is. Color, I'm going with silver. You don't have to put the colors in here for the background. I'm doing it to kind of give you guys a little bit more time if you need it. Solid, liquid, or gas. And this one, you can see it's holding its shape unless I bend it. So if it holds its shape, then it's going to be a solid particle. Element, compound, or mixture. Yeah, it is an element. So that one's an element too. It's on the periodic table of elements. Aluminum, there it is. Element 13 is aluminum. So that's going to be an element. All right, station number 8. Next one on up. You're looking at it. Station number 8. Hopefully you see it. Should pop up in that image there. But it is air. Station 8 is air. Get out of the way so you guys can really analyze it, figure out what kind of substance it is. So you can see it all right there, just hanging out. Looking good. It's good. Best shot I could get of that image right there. But that is going to be air. What's the formula? Or what is in air? Put it in the chat. What's in air? Oxygen. What else? O2 is oxygen gas. Good. Nitrogen, carbon dioxide. Maybe some water particles, water vapors. So there's a lot of stuff in there. So a lot of gases are going to be in air. You have carbon dioxide, you have oxygen gas, you have nitrogen, you have water. So that's made up of a lot of stuff. So this one is going to be a blend of different gases here. So I'm not going to write all these elements down or the things that are in there. I'm just going to put not available. It's several things though. Several things are in this. Phase of air is going to be a gas. Element, compound, homogeneous or heterogeneous mixture for air. Everybody said compound so far. It says mixture. You guys told me that in air you have oxygen, plus you have, get this plus up here, plus you have, oh, it is a plus. Plus you have CO2, plus you have nitrogen, plus you have H2O. Since you have all these things in there mixed together, this plus this plus this plus this, it's going to be a mixture. So that is going to be a mixture, and that is going to be a homogeneous mixture. So homogeneous mixture, a few of you guys got that. Yeah, so it's going to be a homogeneous mixture. So basically, anything you have several compounds together, it's a mixture. I would have taken homogeneous or heterogeneous for this one for air. Homogeneous or heterogeneous. I'll just stick with homogeneous for now. So air is going to be a mixture. You could have said homogeneous or heterogeneous, so to give you credit for that one. All right, next up, number 9. Sample number 9. What it is? There it is. This is a brass cylinder. So it's a brass cylinder for number 9. Brass cylinder, there it is. What's in brass? Which element or elements are in brass? So you guys all have a computer in front of you. If you don't know what brass is, just type in the Google, say, what the heck is brass? Or what element is brass? Faith said copper, zinc, lead, manganese. Okay, brasses are going to be different forms. So the first thing I pulled up really quick, brass, it's an alloy of copper and zinc. So Faith, yeah, brass could be, those are things, and Greg, those, or Alex, those things too. But typically brass is going to be a mix of copper and zinc. It's the ratio of copper and zinc that can vary. So copper and zinc. Another thing I see about the brass is it's probably made of reduction of mixtures of zinc ores and copper ores. That's fine. There's gonna be several things there. But main thing we know, I'm just gonna go with the two main ones in here. It's gonna be copper and zinc. Copper and zinc. Color I'm going with here, that color, I don't know, maybe a yellow, brown, maybe you want to call it gold. Brass. I'm calling it yellow brown. That is definitely be a solid. Element, compound, homogeneous or heterogeneous mixture. The mixture. So the mixture, so that right there, it's going to be a mixture of two or more elements. So it's two or more elements that are mixed together. So the ratio, the key thing is about this one, the ratio or how much copper and zinc that you add to it could change. You could have a different ratio. So solids could be a mixture. This is one situation where it is. This would be a homogeneous mixture. So that's going to be a homogeneous mixture. Okay, station number 10 is going to be lotion. So station number 10, some lotion. Some nice Gold Bond Ultimate Intensive Healing hand cream. But I don't care about the outside of the package. I care about what's inside the package. Lotion. It's definitely a white cream. Okay.
Wait, Mr. Brown, what did you
Yes.
say that my Zoom was like lagging?
It's all right. What do you want? What do you want to talk about? What did I say? What?
For like the whole like last like minute, if you say anything important.
I usually don't say anything important, but number 9, brass cylinders. It's CU and ZN. The color was yellow brown. And then we said it's a solid, and we also said that was a homogeneous mixture. Station number 10, we're on lotion. We said it's going to be a white, and we said solid, liquid, or gas on that one. For lotion, is that solid, liquid, or gas?
Liquid.
Yeah, it's a liquid. Good. So it's a liquid. It's free flowing. It's a little bit thicker than maybe oil and water are, but it's still going to be a liquid. I skipped the symbol and formula. If you look on the back of that, the ingredients there, there's going to be a ton of ingredients in this lotion here. Right by that barcode, you see all these ingredients here. There you go. So there's several things in there together, blended together. So this is not available. Element, compound, homogeneous or heterogeneous mixture. Definitely a mixture. Good, Kai. Kai says it's a homogeneous mixture. It's the same consistency throughout. There's not chunks of stuff in there either. Yes, Joey, it's homogeneous. I knew you had to say that. There you go. Homogeneous mixture. Step number 11, station number 11 is this nice raspberry vinaigrette dressing, light raspberry vinaigrette. If you analyze this dressing, it's definitely pink. There's like little, I don't know what that is, maybe pepper or something in there too. Chunks of pepper throughout the dressing.
I think it might be raspberry,
What's up?
not pepper.
What's raspberry, you think? I don't know, Tristan. Cutting out on me. All right, so this is going to be dressing, salad dressing. Jelly. Looks like jelly, I guess. It's a little bit thinner than jelly, but it's dressing. All right, inside that dressing, you look at the ingredients at the back of that, you can see there's a ton of stuff in there as well. We know there's going to be some probably raspberry, water, sugar, red wine vinegar, distilled vinegar, a lot of stuff in there. So the ingredients, not available. Too much to really handle there. Color, I'm going with pink. Solid, liquid, gas, we know that's going to be a liquid. And element, compound, homogeneous or heterogeneous mixture. Yeah, heterogeneous mixture. So that one is a heterogeneous mixture. Okay, last station. Last one on up. Station number 12. Hopefully you're still with me here. Station number 12 is going to be table salt, which has a chemical formula of NaCl. So table salt is the stuff you put in your French fries. It is called sodium chloride, the chemical name for it. NaCl is going to be the symbol. I think we all know what table salt looks like. There's some table salt in my hand. So table salt. Formula is Na, sodium, and Cl. So sodium chloride. So Na sodium, Cl is going to be chlorine and transfers over to chloride. Color is going to be white. You know it's going to be a solid. Is it an element, compound, homogeneous, or heterogeneous mixture? Yes, Alex. That is a compound. So it is going to be a compound. All right, so that takes care of the data for the lab. Does anybody need more time, additional time to complete that section? All right, moving on forward. So we finished up the 12 different components for identifying a substance here. Moving on forward to the next page. Let's continue on here. So I'm not going to do this entirely. I'm going to do a lot of it, but I'm not going to do basically from this point of 6 on the last page on. So that's going to be assigned for homework, but we'll do this page. Get rid of that L there. Conclusion questions. What's the difference between an element and a compound? You could unmute yourself or you could type in the chat. Once I find a nice solid answer, I'll pull it up and put it in there too. What is the difference between an element and a compound? Okay, Tintin, I'm gonna take yours. I like yours. All right, Tintin said an element cannot be broken down, period. It is in the simplest form, period. A compound is a combination of elements and can be broken down. So that's a good definition. Let's look at some more here. Compounds are made up of multiple elements. Good. Compound is 2 or more elements. That'd work out, Leonardo. Okay, that's good. Michael, that's okay too. Santino, is this good enough? You need to see more. You want me to zoom out so you can take pictures so you can copy it? That's what you want. See, I'm not sure.
I just need to see like the last thing. I got it though.
All right, gotcha. All right, so I'm gonna put Tintin's answer for number 1. Whatever you put, please make sure you highlight it just so I know that's your response and what you want me to check out. Just kind of like what we do for our notes as well. An element, elementary, cannot be broken down. It is in its simplest form. While a compound is a combination of elements and can be broken down. That's a pretty good answer there. So again, please highlight your answer or put it in a different font style. I don't care. Number 2, it says, what mixtures in the lab were heterogeneous and which ones were homogeneous? So please identify which ones are homogeneous, which ones are heterogeneous. I'm gonna zoom out for a second so you can see these. So again, you have to interpret your data. Check out your data from above. Ask for hetero first. So oil and water is hetero. And the salad dressing were hetero. Those are my 2 heterogeneous mixtures, oil and water and salad dressing. Homogeneous mixtures, you can see again, are going to be iced tea, air, cylinders, brass cylinders, and lotion. Let's see if you memorize those. Iced tea, air, brass cylinder, and to get new, we need to add another box here, another row below. So how to add another row, all you have to do is press tab after that. And then we're going to say lotion. Those all have the same consistency throughout. They look the same. And obviously we'll leave these ones blank over here to the left. Okay, next up, number 3. How is the way a mixture combined different from the way a compound is combined? So basically, let's know what's the difference between a mixture and a compound. Please type in the chat. Yes, Tintin, thank you. Yes, Faith, that works out. Yes, Michael. Compounds have fixed ratios, mixtures do not. I'm going with that one. So several of you guys were putting the same type of an answer. Well, Michael's word for word says compounds have fixed ratios. Mixtures do not. The ratios vary. To add another text box below, after brass cylinders, just press tab. Tab over to the left of your keypad. So tab allows you to add another text box down here. And just add lotions. Lotion. No problem. Compounds have fixed ratios, mixtures do not. What is easier to separate, a mixture or a compound? Why? Which one could you separate easier, a mixture or a compound? Why, Jordan? Yes, your answer. It's definitely that, but why? Okay. Nidal, nice answer. It's all right, Jordan. It works. Jumila, nice answer. All right. A mixture, because mixtures often have physical properties and can be separated, analyzed, you put. A compound is a combination of elements, so it'd be much harder to separate. It works too. Okay, more of Alex's answer actually. A mixture is easier to separate because they aren't chemically bonded. They're physically blended. So I'm gonna go with that one. So a mixture because they aren't chemically bonded. Because they are physically, I'm gonna say because they're physically. They are physically mixed. You could easily separate them because if you physically separate it by maybe filtration or distillation or chromatography, then you could separate those mixtures in the solution, or evaporate them. Could be another way you could separate them too. A mixture because they're physically mixed together. Blended, I'll say, instead of mixed again. Blended together. So like the oil and water, you could separate the oil and water relatively easy if you just pour out the oil first and then you separate the water. Or you could pipette the oil out and put it into a different chamber. There are several answers that could work out for that one. I'm going with that one specifically. Excuse me. Okay, that's number 4. Number 5 is going to be several questions here. We're interpreting these little particle diagrams to figure out if it's an element, a compound, or a mixture. So this number 5 is like 15 different questions or parts of this. Let's go through at least 5 of them. Okay, question number 1, we have these particles here. They look like they're in the gas phase. Let me look at the rest of these. Yeah, all these are actually in the gas phases. So you can see that they're taking the shape of the container. They're spreading on out. They don't really like each other. They're just spreading all out for these. The first one, number 1, we're analyzing it. I know if it's an element, compound, or mixture. We have 2 clear ones. Now they have 2 green. And then you have 1 black. You have 2 green, 1 black. 2 green, 1 black, 2 green, 1 black. So every one of these particles here are exactly the same. There's 2 clear or green, 1 black. This is going to be a compound. So this is like H2O. There's 2 H's, which would be the clear ones, and then there's 1 black one, which would represent the O. This would be water molecules, H2O molecules in the gas form. Choice 2, is that an element, compound, or mixture? Yes, Kai. Yes, Michael. So a compound would be like H2O. You have 1 O, you have 2 H's, chemically combined in fixed ratio. So in this situation, you have 1 element, which would be maybe the transparent one. There's that red element, transparent one. But you also have the black element too. So you have 2 different elements in this situation. So you have the red one, you have the black one. They're both in gases, and they're both going to be mixed together. So that one's going to be a mixture. They're not bonded to each other. Yes, if you only had the black spheres in here, that would be an element. If you only had the red ones in here, that's an element. There's no compound because they're not joined together. They're not like right on top of each other. So it's got to be at least an element. There's 2 elements mixed together in the situation. So that's a mixture. Number 3, element, mixture, or compound. So analyze the particles. Yes, Joey. So I have 2 spheres together. There's 1 compound. So that's 1 compound. Yes, Kai. But then I have a different one with 1, 2, 3, 4, the yellow, and I have 2 black. 4 yellow, 2 black. This one would be 4 yellow, 2 black. Here's a different compound. So that's the same compound, same compound, same compound. In this situation, since I have 2 compounds mixed together, 2 different compounds mixed together, this is a mixture. Number 3, let's check that one out. 3 we just did, mixture. Number 4. Element, compound, or mixture. Number 4. So I have 1 compound, which is like this. So I'm going to color all these ones in red. That's the same. That's 1 compound. But then I have another compound that's here. So you have that plus that. So you have the red one plus you also have the yellow one. That is going to be a mixture as well. Number 5, what's this one going to be? It's all black spheres in there as a gas form. Nothing else, just all black. Gas form. Yeah, it's going to be an element. Let's just do number 6. Which one's 6 represent? Element, compound, or mixture? So I'm analyzing, I'm saying, oh, these are all the same. It's not just one little particle by itself, it's several particles bonded or blended together. This is going to be a compound. All right, so for homework, you're gonna have to finish up the rest of this. You're going to have to do the rest of this page, so all the way to number 8. For your answers, I guess just highlight your answers, whatever the answer may be. Just highlight it, or you can put up here, I don't care. Highlight it or put in the answer. I forgot I had that portion there. So you're doing the rest of that. Once you're all done with it, this is going to be due on Saturday. Please share it with me at jebrown@uticaschools.org. So please submit that to me. Please finish up this lab. Thank you for coming on the field trip today and experimenting with this lab today. That's it for the first portion of today's class. On to the second portion of the class, which goes to our classroom page. Now we're on to the atom. So we're gonna go Unit 3, the atom. I'm gonna play a quick little flick on this, and then we're gonna get into our guided notes. Really transition to second portion.
What do an ancient Greek philosopher and a 19th century Quaker have in common with Nobel Prize-winning scientists? Although they are separated by 2,400 years of history, each of them contributed to answering the eternal question: what is stuff made of? It was around 440 BCE that Democritus first proposed that everything in the world was made up of tiny particles, surrounded by empty space. And he even speculated that they vary in size and shape, depending on the substance they compose. He called these particles atomos, Greek for indivisible. His ideas were opposed by the more popular philosophers of his day. Aristotle, for instance, disagreed completely, stating instead that matter was made of 4 elements: earth, wind, water, and fire. And most later scientists followed suit. Atoms would remain all but forgotten until 1808, when a Quaker teacher named John Dalton sought to challenge Aristotelian theory. Whereas Democritus's atomism had been purely theoretical, Dalton showed that common substances always broke down into the same elements in the same proportions. He concluded that the various compounds were combinations of atoms of different elements, each of a particular size and mass, that could neither be created nor destroyed. Though he received many honors for his work, as a Quaker, Dalton lived modestly until the end of his days. Atomic theory was now accepted by the scientific community, but the next major advancement would not come until nearly a century later, with the physicist J.J. Thomson's 1897 discovery of the electron. In what we might call the chocolate chip cookie model of the atom, he showed atoms as uniformly packed spheres of positive matter, filled with negatively charged electrons. Thomson won a Nobel Prize in 1906 for his electron discovery, but his model of the atom didn't stick around long. This was because he happened to have some pretty smart students, including a certain Ernest Rutherford, who would become known as the father of the nuclear age. While studying the effects of X-rays on gases, Rutherford decided to investigate atoms more closely by shooting small, positively charged alpha particles at a sheet of gold foil. Under Thomson's model, the atom's thinly dispersed positive charge would not be enough to deflect the particles in any one place. The effect would have been like a bunch of tennis balls punching through a thin paper screen. But while most of the particles did pass through, some bounced right back, suggesting that the foil was more like a thick net with a very large mesh. Rutherford concluded that atoms consisted largely of empty space, with just a few electrons, while most of the mass was concentrated in the center, which he termed the nucleus. The alpha particles passed through the gaps, but bounced back from the dense, positively charged nucleus. But the atomic theory wasn't complete just yet. In 1913, another of Thomson's students by the name of Niels Bohr expanded on Rutherford's nuclear model. Drawing on earlier work by Max Planck and Albert Einstein, he stipulated that electrons orbit the nucleus at fixed energies and distances, able to jump from one level to another, but not to exist in the space between. Bohr's planetary model took center stage, but soon it too encountered some complications. Experiments had shown that rather than simply being discrete particles, electrons simultaneously behaved like waves, not being confined to a particular point. And in formulating his famous uncertainty principle, Werner Heisenberg showed it was impossible to determine both the exact position and speed of electrons as they moved around an atom. The idea that electrons cannot be pinpointed but exist within a range of possible locations gave rise to the current quantum model of the atom, a fascinating theory with a whole new set of complexities whose implications have yet to be fully grasped. Even though our understanding of atoms keeps changing, the basic fact of atoms remains. So let's celebrate the triumph of atomic theory with some fireworks. As electrons circling an atom shift between energy levels, they absorb or release energy in the form of specific wavelengths of light, resulting in all the marvelous colors we see. And we can imagine Democritus watching from somewhere, satisfied that over 2 millennia later, he turned out to have been right all along.
All right. Sorry, I cut that video. Chris, you got everything there. Oh, there you go. All right, so that's a video. So now we're actually going to study the development of the atom. So welcome to chemistry. You definitely have to know what the atom is for this course. We're going to really break this up quite a bit, but we're going to start off with a little history lesson today and next class on the history of the atom. So please open your guided notes. It says Unit 3, the atom, guided notes. Should be a blank copy there for you. Go to classwork, go to Unit 3. Again, I'm not gonna put these tabs at the top. I like this order here. It's like a little book. You know which page you gotta go to. You gotta go to Unit number 3. And then you can find, boom, Unit 3, the atom, guided notes. So please open that one up. Yours is gonna be blank, I assume. Okay, yours should look like this. And we're going to be filling in the missing links here for our guided notes. So you can see that there's 6 different topics. We're going to start topic number 1, history of the atom today. This unit is going to go relatively quickly, so I do plan to go relatively quickly through this. It's not going to take too long to really copy the notes here. There's not going to be a ton of pictures we're going to be making. So we will be going through this at a nice rate. So that is the notes we're going to be filling out. We additionally need the guided notes, which would come from right below. It says right here. It says, there it is. So below our attachments, you have this, which is our guided notes. Maybe I'll just leave it on this feature here. All right, so the guided notes we could copy from the left and work on transferring it on over to the right. So hopefully you're situated. Additionally, in the future, you're going to need a reference table or periodic table as well as we go through this. So figure out what screen works out for you, figure out display how it works out. But it's the same routine as we did for the last 2 units, so keep it on up. All right, so the atom. Try and make this a little bit bigger for you, but it's not really working out. Probably have to download it first. Just open up somewhere else. All right. Don't know if it worked out. But I'm going to fill it out anyways. Here we go. The atom. So in the atom is going to be the basic building blocks of matter. So basic building blocks of matter. I'm going to fill this in here. Please, again, highlight your information. Basic building blocks of matter. Just like above my shoulder over here, we did this little flow chart. There's matter up on top, but then we analyze the atom right there. So basic building blocks of matter. More information about an atom. Cannot be broken down chemically. And a single unit of an element. So an atom is a single unit of an element. So if you're just talking about one specific element, one specific piece of an element, that's going to be called an atom. A single unit of an element. So an atom builds basic building blocks of matter. It can't be broken down chemically. It's the simplest form of matter. And a single unit of an element is an atom. So the development of the atom started off with the Greeks way before 1803. So the Greeks started talking about the idea of what things are made of by just saying atomos. So they said atomos. And then they didn't say anything about what an atom was. They said everything basically is stuff. They didn't say it's protons, neutrons, electrons. They just said atomos, which meant things are made up of things. There's no science behind it, nothing. Then in 1803, John Dalton came by. He's known as the founder of the atomic theory. So he's known as the founder of the atomic theory. These are pretty good postulates to know, be aware of. If we're in school, I'd say, hey, memorize this. So again, what I'm doing, I'm just copying the notes to the left down to right. He's known as the atomic theory. In the atomic theory, what happens here, he said that all matter is composed of indivisible particles called atoms. He said all atoms of a given element are identical in their mass and properties. And if it's a different atom, atoms of different elements have different masses and properties, like all gold has the same property as gold. All oxygen has the same properties of oxygen. Gold and oxygen have different properties. The third one says compounds are formed of combinations of two or more atoms. Hey, that's what a compound is. Compounds are formed by combination of two or more atoms. That's the definition for a compound. The fourth one is it's a law of conservation of mass, so that's a good one to know. Atoms cannot be created, destroyed, or converted into different kinds of elements or atoms during chemical reactions. So those are the four properties that you should definitely be aware of from what he proposed back in 1803. And that's pretty groundbreaking stuff because they didn't really have much science to really back it up. He just came up with this postulates, and a lot of this was pretty accurate. His theory of the atom is called the cannonball theory. Cannonball theory. Cannonball. Cannonball is one word. Cannonball theory or model of the atom. That blue sphere above is representing what his atom looked like back in 1803. His atom. So what's going to happen, we're going to look at the evolution of the atom as it with a picture as well. It was spherical. It's like a circle, like a cannonball, and it had uniform density. So it was circular, and it was the same throughout, just like a cannonball or a bowling ball. It's the same consistency throughout. You didn't talk about a nucleus, didn't talk about proton, neutrons. something called electrons. We didn't talk about that back in 1803. Very basic from the get-go. Okay, instead of me starting J.J. Thomson going through his model, I'm going to stop class right there. You can see where we're going and what we have ahead of us. But it's going to fly by. It's going to go by relatively quickly. So definitely next class we'll go through the history of the atom. We'll talk about subatomic particles as well. But on this note, don't do the exit pass yet because you can't do it. And you have to complete the lab though. Please do that. And I'll see you guys next time. Please make good decisions. Have a good day. Stay warm, stay dry. And see you next time. See you guys. Have a good day. If you have questions, hang out.
Have a
I'll be
good
around.
day.
Thank
Have a good
you,
day.
too.
Have a great
See you
day,
later.
Mr. Brown.
See you later, guys. Have a good one.
Gucci.
Gucci. Have a good day, guys. Bye, Kim. Bye, Irvin.
Mr. Brown,
Yes.
did you get my email?
Let me see who I'm talking to first. Jordan, I did.
Jordan.
I had a few emails. I didn't respond to yet because I had a full class today. My first break's right now, so I'll get back to you.
Okay, I just want to make sure you saw it.
You want to talk about it now that no one else is on? Let me stop. Hold on
Sure.
for a second. Let me stop my recording.